I learned a new phrase the other day, vibe coding. That is, instead of writing code with your heads down, you just lean back and tell the AI what you want to make and say, sure, accept, apply, and then just let the application emerge from the conversation versus real mechanical programming and syntax. And that's the power that generative software has brought to the imagination of people who weren't programmers, but they're looking at the capability of these OpenAI, Claude, Sonnet capability and say, hey, maybe I can make software for my own use. So today I want to talk to you a little bit about generative software. And we believe that generative software is not only the most exciting thing, because it's not just about creating content and media of some sort using AI, but creating really useful tools that can help people accomplish a goal in a way that they either couldn't do because they don't have the technical skills or couldn't afford it because people with technical skills and teams are expensive. So software is now becoming a commodity, not because of open source or sharing or app store, but it's because the software can be conjured up from your words and from your ideas. So today we're going to look at whether generative software is the next step in AI, and if so, how can we improve the ability to make generative software even easier for people to adopt. So I saw this tweet about Replit agent, Lovable, and Cursor, three of the leaders in generative software. And Nick said, is it possible that we are still stuck in the old paradigm where we're adding software generation to a code editor, something that's like a developer or dev environment? Is there a way to kind of do a TikTok where when TikTok came in, they came up with CapCut, which is a video editing tool that generates all the video that you see and people have a lot of fun with it, but it certainly doesn't look like the really serious professional video editing tool. Could software development tools for generative software, for vibe coding, evolve in that direction? And what would that look like? How do we move beyond this super high-end and still very complex dev environment with AI on top into something that's natively supported? So in my opinion, I think to get to this point, it's not just about improving the models and making generation better, but it's to revisit whether the software stack of the software you generate that runs on, do we need a new stack? Is there a way to fundamentally rethink software so that generation and the AI can be much more compatible with this vibe coding going on? So before we can answer this question, I'm going to go and step back and say, let's take a look at the state of generative software as of February 2025. In a couple of months, if you watch this video, everything I say here will get out of date. But I just want to have a snapshot of what are the current tools, what are the current workflow, how are people calling themselves software composers or vibe coders are successful in expressing themselves in this new emerging generative software medium. And then we'll see whether the current software stack that we have learned and loved, the full stack cloud software, maybe is limiting what we can do with AI, and propose a solution. This is the work that we are doing here at Cardstack, which is creating an AI native, something that is much more compatible with AI wanting to chat with you, share files with you, going back and forth. Is there a better way of rethinking the software composition process and framework so that it can actually jive with the direction of this type of iterative software development that is happening in minutes and not in weeks or months? So the state of generative software is dependent on something called large language model. Large language model is something that applies to text, images, codes, data, and files. So this is not specific to software, but large language model sucks in everything from the internet and essentially run it through a training process to compress almost the world's knowledge into this model. Right? These are called model weights, and they have different names. Different training runs have different code name. GPT 3.5.4 was the OpenAI famous groundbreaking version. Claude Sonnet 3.5 is the current leader in software, and then Meta is doing an open source model, and there are new competitor from China like DeepSeek R1 that has took a different slice of the internet and the training set and creating these models where once you put it through some inferencing, which is using a GPU to generate new data based on prompt, it will create new stuff. So it's kind of like learning something and ask it to create new things. And that type of language model exists for different types of medium, text, to interpret PDFs with files, that data analysis ones. But what we focus on today is on code and related sensor data. So after the training run, most of these LLM know something about coding. So by analyzing tons of code that's on the internet, it learned JavaScript because JavaScript is a lingua franca of the internet. It knows React, the predominant language. It learns UI library like SHA-CN UI, which has components for dropdowns and things like that. It learns Python, it learns JSON, all kinds of different types of techniques to lay out things using cascades and style sheets are all internal to the LLM. And when someone say, I'm generating software, think of it as retrieving this knowledge and adapting it to a use case and making something. The same way when an LLM knows a language, you can ask it to say, hey, translate this particular paper into this language. And it draws upon this kind of inherent knowledge to do this generation. So the first time I saw generative software really kind of blow my mind is when Code Interpreter, which is a features in ChatGPT that comes out and say, I can just ask it to say, plot the average temperature in NYC for each month and the hotel rate. I can certainly write a piece of software to do and get data for it. But ChatGPT here wrote some Python code and generate some data based on its understanding to then give me this graph, which means that as the temperature gets warmer, it gets more expensive. But then it also doesn't get cheaper as it gets cooler again because it's a holiday. So maybe the best time is around this time, February, March, to visit for, I guess, decent room rates and such. So this is server-side generated. So the code, Python is a very AI language. It's something that people who do training all use Python as a toolkit. So it's just natural that the first generative software will be generating Python. However, the real breakthrough came when Claude, which is a competitor to OpenAI, came up with something called Artifacts, which uses the Sonnet model, which is another model that's in the training run. And this is a client-side concept, which means that it is something that runs in your browser. It generates some code that it's just kind of running only in your browser, no server-side stuff. It uses iframe technology. And this was a really revealing moment, which means that you can now prompt it to say, hey, I want to create an artifact, which is what they call these kind of iframes, to play with some tile size. So this is actually my prompt. I want to play with a tile system, a way of thinking about different sizes and the quantums of the sizes to make a composable framework, which is what we do here at Cardstack. But instead of drawing this in Figma in a design tool or having to write CSS to test it out, just with a couple of prompts, I was able to generate a thing that I can play around with the thing. So this type of prototyping tool is quite transformative. Once you make this app in 15 seconds, you're able to play with it with a visceralness, knowing when things are too small, too big, sizes sensible, what can I put in it? And obviously I can prompt and make it even better. But just being able to play with something in such an immediate sense really shorten the thinking cycle and the way to communicate with other team members or developers what it is. So this Sonnet model extracted all the knowledge about how to make really good UI, and as well as open source libraries such as drop-down library, drag and drop library, and then put it together with good aesthetics. So there's a lot of imagination that happens where people start generating these artifacts that taps into its knowledge of games, WebGL, which is a 3D way of doing things. And that's when people say, wait, I can now throw these programs that would have taken weeks, if not months to build, and we can prototype a version of it, whatever can run in a browser window in minutes, if not in some kind of seconds. This is still the best model that exists today, and it writes React code. So this is not something that is a facsimile of a widget. It's actually the widget library. You can copy and paste it to a code base and actually use that little tile control that I have in a real live app. So Sonnet 3.5, which is the model, included in the Claude platform, which is a chatbot, this idea of artifacts. But when a model exists and comes up in the AI field, not only can you use it through the official UI, in this case, a chatbot, a chat UI, you see other projects and companies starting to tap into this new capability of this amazing coding skill that exists in this model. And there are two companies I want to talk about that has really kind of taken this breakthrough and open up new opportunity space. One of them is Websim. They went ahead and allowed this remixing model to become more like a social network where you can see what people have generated in the last hour or weeks or days, and then you can remix and make your own version. No GitHub required, no need to check in your code. It's all kind of like social media experience of sharing and iterating not only the content, but the template itself. So that's really interesting. That's the fun social stuff. At the same time, the Sonnet model also made it much easier for people to tap into that capability within a existing professional coding environment. So Cursor, which is one of the most successful, maybe I think the fastest growing SaaS company ever in terms of annual revenue, recurring revenue, they took the Sonnet model and tapped into a fork of VS Code, which is a coding tool, and then allow you to now ask the AI to fix bugs for you, to add features, to make refactoring changes. And then that becomes essentially an augmented development idea that while it's not a particularly new thing, it just because of the model breakthrough worked well enough that people are now gravitating and say, hey, if I don't have this tool, then I'm not going to be able to keep up with the pace and the skill set that's out there. So let's take a look at the Websim, and then we'll go back and kind of look at the code edit aspects of it. Websim started out as a faux browser where you can just type in any URL. I came up with this URL, local foods market, local market /search text.x. Eggs are hard to come by right now, so I want to see if I can get some hallucinated eggs from the virtual AI market. And based on that URL, it generates a plausible page. And if I click on farm fresh egg, organic brown egg, it will have a URL and I'll follow that. So it's a way of browsing the AI's hallucination, dreaming of new web pages as you come. That's how it got started. So one way to think about it is that the URL is the prompt. And based on the URL, what would a web page with this URL look like? It generated a plausible looking local foods delivery service. But now, with some iteration and community feedback later, it has evolved into less of a browsing as a single person surfing the latent space, but actually a real concrete sharing of these pages that may have started as a URL, but you can add additional prompts to refine that page. Say, hey, make this page blue, add this button. And maybe at some point that actually becomes a working application, not just a imagined application, but something that has the code, the hosting and the data and the ability to tap into AI capability that you can go and create image generators and article generators and whatnot. This is, I think, is the hot pages of the recently voted up or heavily accessed contribution from the community. One of them that is a Squid Game scene generator. I think that's pretty cool. But what we can see on the right side, on the left side here, is that these are the add chat room. You can chat and message, add mini game, add tags, upgrade survival pentathlon. These are the prompts that the person who is generating this game has added. But notice the remix stuff. The remix means that someone from that point, some other user is actually making a different game or different direction. So it's a very social experience, kind of like what making duets and stuff like that, but not side to side. So that's kind of the idea here, a social experience. But underneath the social experience is still some of the underlying files. So this is going to be a key phrase. The files is what the AI is generating, right? It's generating the new JavaScript file for the app, the leaderboard, the mini games. It generated style sheet for the look and feel for this neon magenta look and feel. But you don't need to see the files, right? The files are just behind the scenes. The social experience, the actual rendered application output is what the user cares about. With Cursor, that's less of the case because this is a development tool. So you're mostly working in a code editor. And when you go and say, I would like to change this and add this new feature, it actually does a call to the Sonnet model. It actually uses the same model. But Sonnet has one problem. It has something called laziness problem, where in successive conversation with Sonnet, say, hey, change this font or add this button, it will come back and say, okay, I made a new button for you, but the form or dialogue itself is exactly the way it is before. And then we'll use a comment to just say, yeah, I haven't changed this part. But if you just run that code in an artifact, your code is now missing a key piece that existed in the previous generation. So your thing breaks. So Cursor is essentially using a code environment as a persistent memory. It's like, I kept the version of page.tsx, this file. So when Sonnet say, I'm going to add this feature, it knows that it's overriding or adding new things to the existing file, and it added something called an apply model, which is a way of diffing, figuring out what the differences are. And after Sonnet returns as somewhat lazy and shorthand results, Cursor will find a way to patch them together, find pieces, and these green things are insertion and the red things are deletions, so that when you click apply or accept, it is a complete document or complete code base that has everything that happened before plus the changes in addition right now. And that is so much better than having to manually copy and paste and figure out what versions of the previous run you will need to make a working application. And this was a huge hit. The ability for doing this kind of accept and reject at the code editor level. If you're a developer, you can go ahead and speed up your thing and review the code. But what's most exciting to people who are non-developer for Cursor is that despite this being a developer tool, if you're non-developer and you just ignore these kind of specific changes that requires you to review and just like accept. This is what vibe coding is, which is like, I don't know how to code. The LLM knows how to code better than I am. I'm just gonna let it do its thing. People are able to, within minutes and some hours, and generate full application as if a developer wrote it in VS Code on this coding environment. So the current generative software landscape is really divided into three parts. One that still has its root in chat UI. So these are the model providers like Claude, OpenAI have their own ChatGPT applications, and newcomers coming in that's mostly helping you generate code by chatting with this. I want to make a CRM, I want to make a leaderboard, whatever it might be, and it delivers it within that environment. And then on the more professional side, there is these code assistants. Actually, the first one was coming from GitHub called Copilot. Cursor has kind of one-up that, and I know Microsoft is making new investment to make that even better. Replit, which is a very good tool for people who want to do web-based development where you don't need a powerful computer, you can just have your development online. Those are full IDE, integrated development environment that's now adding these chat features. So it's inclusive of the chat UI. And on the other side, you have an organization like Vercel, who has a V0 product, started as a prototyping product for making UI. And there is also the ability for you to share these components with other people. And Lovable is a new entrance that came in and then growing like wildfire to actually iterate on templates and share and host your application. So the truth is that these things are all kind of blended together with different brands here, kind of expanding to this full page. But there is this social chat-based code editor things that people oscillate back and forth between. So these are leaders that if you guys haven't tried it out, I would love for you to kind of learn and tell me which one syncs up with your sensibility. But one of the things that comes for people who have been trying to make real production level application using these tools is that they face a problem of each tool not being good enough to be the only tool you use. And that's not a new thing. There's an idea called software development lifecycle, SDLC, which engineers and software developers use to organize big projects, things that involve multiple people. And the rough lifecycle is planning, analysis, design, implementation, testing, and maintenance. So if you have a project to do a big upgrade or big installation, you're going to go through these steps. So I think we are in a stage where we have essentially emergent within the field of generative software this idea of a software generation lifecycle, SGLC, which, by the way, has the same steps: planning, analysis, design, implementation, testing, integration, and maintenance. Except these steps are optimally created or made using different model. There are different AI tools that are better at some phase of it and then others. For example, if I want to do coding implementation, Cursor is the best tool. Everybody knows that. Even bug fixes and testing and integrating new APIs, Cursor knows how to put it together. But to like get an idea of what you want to build, what feature would make sense, what kind of objects you want to make, what kind of feature, what kind of component would make sense to be integrated, what kind of software stack you want to use. You want to use a thinking model, a model that gives itself more time to analyze the problem. And OpenAI has some thinking model like O1 and O3, relatively new. And from that process, then you can have essentially a product requirements document, a long text document in Markdown or text format, that you can take it to a design tool, a tool that is better at constructing amazing looking, polished design like the V0 product of Vercel or Lovable. And from that, you take that code base, and that's when you bring it back to a more professional environment like Cursor, and then you deploy it somewhere. So this software general life cycle is getting people to understand the missing pieces are not just the actual coding part, but what comes before coding, the planning and design, and goes after the implementation of the hosting environment. So looking at the OpenAI model, so one example of this is that let's say I want to make a daily report summary system. Instead of just saying, hey, code this, I go into Cursor, it wouldn't know what to do because this could mean so many things when I just say I want a DM and then I want a schedule. But if I send this text with no context beyond just what this prompt is to O1, it start give me a plan for the application architecture for the front end and back end. It gives me a data model, what tables I would need. It gives me a flow of when something happens, when a scheduled task will run. It gives me a instruction on how to set up the project using these command line to set up the project. It creates different type of database structure I would need, being able to deal with deployment and access control. So if I have this planning document, a product requirements document, or PRD, then I can have much more information to share with the next AI that is doing design or doing implementation. So it's a really powerful thing to go from nothing to a plan and from the plan to the code itself. On the flip side of this, after you've gone through all this code generation, you now have to deploy this app. Now, Websim, no deployment necessary because it's the social network. But for these kind of more professional, more like traditional development environment-based tools, you still have to go and figure out what your domain is, deal with the billing, get API keys if you're calling different APIs to extract YouTube thumbnails or call API keys for AI. Deal with authentication, monetization, Stripe payment. And then when you've done all that, you set up the environment variable, which are a way to keep your keys safe so it's not on the web page. Then you can deploy to either Replit or Vercel as a way similar to how a developer finishing a project, a coding project would deploy. This part isn't particularly unique to AI. I think a lot of people who are able to like generate an artifact, just have a game to play with, struggle with dealing with all these technical concepts of figuring out the cache and the cron jobs. These are all very jargon. We still have a very extremely technical assumption there. So this is the current workflow between planning, analysis, design, implementation, and maintenance. OpenAI and DeepSeek's thinking models, very important for planning. And then that goes to a V0 for editing, Cursor for implementation, and Replit and everything for distribution. As people become more proficient in generating software using the aforementioned tool, I think people are starting to realize that there are some inherent problems with the software that AI is generating. So one way to look at this is to say that AI has learned a lot of things. They know the basic idea of JavaScript and everything on the programming language and syntax and how to write certain functions and data structures or algorithms. But when you ask it to make a particular program, it's going to look at things that already exist in the world of GitHub, which is a sharing community for software, and on the web. It's like, have someone made something like this before? And most of the time, when we say we want to generate software using AI, we're asking it to generate software that is in the stack that we know, such as the full stack application. Oh, I want you to write some Python. I want to write some JSX, which is the React way of doing templates. And if it uses a database, I want you to write SQL. It may be that there's configuration to make it work in a certain type of environment or cloud to command line. These are all skill sets that the AI will largely comply with. If you want it to write something in Python, it will give you a Python program. If you ask it to write something in a more archaic programming language, assuming there's enough content in the LLM training data to do it, it will do that gladly. But the problem of after the generation is done is when you want to make revision to this, call it template or starting point, you now have to make changes everywhere. If you want to add a birth date field to something, or you want to add a new tab or features, the LLM have to look at the whole code base with all these different files that interact with each other and say, oh, let me see, is it in the API? I need to add this in the UI, in a database, and in the cloud, the way we use services to add new images or whatever it might be. And this is what developers do. Like when you have a large team, you have different people working on different things and making sure that things are aligned. But in a vibe coding thing where you're just accepting it, sometimes it misses things. So you have to cross your fingers and hope you get good luck and say, hey, maybe this will keep working. But once you get to a problem, then you have to keep saying, hey, I have a problem here, fix this. My database is not returning in result, fix this. And that type of fixing becomes a predominant work, which is fix this, copy and paste the error message, not really thinking about adding new features, but just struggling with the alignment of the different layers of the stack as you're making changes to a larger and larger and larger code base. So LLM can do this, they understand, but the more sprawl you have, the deeper your stack, the more things that deal with, the more naturally bugs and missing pieces and misalignment happens. In addition to that, there's also, when the LLM is generating, it also doesn't have a full view of your application. It can see the code, it may see some like sample data, but if you're running images in the cloud or you're uploading data to a database, a lot of the LLM that's generating code doesn't have the ability to see that. So a lot of times, hey, nothing is showing up. Maybe you have nothing in your database. It doesn't know that, right? So there's a little bit of gap between the LLM on one side and then the traditional stack kind of stuck right in the middle, dividing the visibility to all the images, files, and codes, and data, and text, and content that an LLM is perfectly able to process, but the stack prevent access in that kind of symbiotic way. So code generation is kind of a one-way street into a stack of a somewhat sprawlish stack, and you hope that you can maintain that over time. And the maintenance aspect of it is no easier than maintaining a traditional full stack application process. So that's the stack as we know today. This layer software stack has really been the dominant architecture for software for about 14, 15 years, since the beginning of the 2010s when cloud software became the norm. And one of the reasons it's so successful is because you can build extremely scalable services like Google or like Apple or Facebook using some version of this stack or these approaches. And if you think about what big tech companies do, is that they have on staff hire different engineers of different type for the tooling to be able to do programming. They have tooling engineers. They have front-end developer or front-end experts dealing with JavaScript or even as it relates to mobile application. They have architects building microservices, a way of orchestrating many different type of API working together, doing login, logging, image generation, all this kind of stuff. And then database, scaling more data. As user give you more and more data, you have like billions of records, you have to deal with that, distributed systems, and then making sure that everything runs and keeps uptime high. That's what staff's site reliability engineer, SRE, come into place. So the layer software stack we know today is really optimized for big human teams in big tech companies. But why do we really need that? Because that complexity really can be compressed so that it's easier for a single person to deal with it. And that's the work that we've done at Cardstack, which is there a way for us to put an anvil on top of this thing and compress by selecting a subset of UI, API, database, cloud, and front-end development technology so that a single developer can just learn one thing, TypeScript, which is a variant of JavaScript that is, pretty much well known. More importantly, the LLM knows it for sure. And then by making it simpler for an individual developer, the AI, which is an individual, right? It's one kind of context window, one brain that's generating these things, can just express all of the output in a much narrower scope than to try to spread it out towards the traditional full stack application. So with the compressed stack, we can just assume that all the complexity is already contained within this, layer, this runtime of sorts. And we can start thinking about how LLM would prefer to deal with the different things that is the content on top of these applications. And one way to think about it is that the LLM itself has a bunch of knowledge. That knowledge, it's not like anywhere. There's no files anywhere you can do. It's just a giant model. So think of it like a muscle memory, where when you train yourself playing tennis or basketball or learning how to play the drums, after a while, you just inherently learn the muscle memory of those movements. And there's no way of pinpointing what you don't know. It just is there. But when someone say, hey, I want you to do something, a chat or a conversation, that's when you say, hey, here's a short-term memory. Here's some information that you need to know to do the work for me. And that information is also available, let's say you want to play music, it's like a sheet music or something like that, that's in a long-term memory. You pull something from a library, long-term memory, give it to the drummer in a short-term memory, and then they use the muscle memory to play the thing. But if you think about this not just as a kind of human learning skills, but to think about LLM dealing with these media types of text, images, code, data, and file, which, by the way, a lot of these models doesn't really distinguish between a lot of those things, whether it's code or data or text is all the same. You chat with it and get at that. So what end up being the key to allowing you to tap into the application capability of LLM is to figure out how to get information in and out of the context window, which the most common way is through chat UI. So send in some text and images, such as make me an app that look like this app, take a screenshot, and then it gives you code. And then you say, hey, now give me some sample data that would fit into that code so I can play around with it. So that would be a short-term memory. But how do you know to send that image or that text over? That's when you have a separate system that may keep track of all your images, all your prompts and stuff like that. And that's more of a traditional SaaS application, more like a database. What's actually going on in these applications, whether that's Cursor for code generation or even using Sonnet, is that you're uploading files from long-term memory, your computer or another part of your app, and then you're adding it to the chat. The chat then use that context information to do the generation, and the output of that is something that exists in the chat, and that's sometimes good enough. You just need a question answer. You ask to say, what is the price of this thing, or what is the recommendation for a product? But if you take that data and you write it back to your long-term memory, then you can query. You can say, oh, I remember asking or generating this report or this contract from an LLM. Can I find it based on the date or the client ID? You want to be able to get that information into a more traditional database and then be able to retrieve the long-term memory. The reason why this is so good is that this is a loop. It doesn't really change, doesn't really stop, right? Once you've added something into your long-term memory by copying it out of the chat, you can now send that information again in the next prompt with the same or different LLM, and then you get new results, and then you save that. So this loop of between the short-term, long-term, and the muscle memory is the core principle for how application built on top of AI actually work. Depends on whether you're dealing with code. These short-term and long-term memory will look like a code repository and a chat or composer window in cursor. If you're dealing with something more like images, you'll be dealing with saving, downloading PNGs and re-uploading if you want a version of your wallpaper. So that's the idea, is that every single application is going to have some version of long-term and short-term memory. In our particular vocabulary, we think that the long-term memory is an app. It has a UI that's familiar to people, like a workspace to create and edit and search for code. And then chat are sessions. So you can start different sessions with different LLM, maybe one with that's a smarter model or around coding, and then if you're dealing with image generation, you use one that can interpret your prompt and do image generation. Either way, if you look at it UI-wise, the left side of the screen would be a traditional app, and the right side of the screen would be an AI assistant. That's kind of how we see app and chat UI working together, leveraging long-term memory to feed into short-term memory and extracting information back in long-term memory. So you don't really need to constantly ask the AI what it needs to generate if you already can find it quickly. And the muscle memory part becomes somewhat commodity, right? So instead of using one model and say I'm using Claude website, I can only use the Claude model. You can choose between different models, and depends on what your needs are to engage in a particular skill set that you believe that model is particularly good at, you can choose to do that within the chat window. Now that we've covered how we can simplify the software stack so that AI can speak the language of files going in and out of its capability, let's take a look at a particular architecture that we've been working on Cardstack to create an AI native software composition environment and framework to make this so that it's concrete. So AI native software composition basically acknowledges that people want to build AI apps, but they don't want to build the stack. So if a stack exists and it's something they can depend on, then they can be very creative about what kind of app they can build. Because if you accept that there are different modalities of interactions with AI, through a code editor, through social UI, through chat UI, you don't want every AI app to repeat building a code editor, a social feed, and a chat UI over and over again. It would be good if those parts of the capability exist in this AI native stack, so the AI app just has to focus on using this capability. So let's take a look at what it looks like under the scene. And this AI software stack is what we've been working in called Cardstack. And it includes the supporting functions and infrastructure that makes the stack look like a file system, so that if the AI just wants to save a file, write some code, save it, it can access the stack like a file system. But if you're building a social UI and you want to filter and sort, you want to be able to query that in the database. How do you query a file system? So we will also expose this underlying capability as a database, as you would need to build type of social or database or SaaS-like experience. But if you want to say, hey, I just want to tell the AI to make some revision, we want to allow you to tap into a chat interface to extend or augment or revise a particular operation that's happened. So this file system, database, and chat network needs to be not only available, but integrated behind the scene. So let's take a look under the hood of the current shipped and launched and running Cardstack infrastructure that is supporting a lot of AI apps. So the seamlessness means that there's only one kind of layer. This is the bottom layer that's been compressed that contains the file system, a database, and chat network in a infrastructure. What the user or developer is doing is placing code and data as files in the file system. So code, we have chosen TypeScript, TS, as the programming language because it's all the same. It doesn't really matter what programming language you chose. The best thing is to choose a language that the LLM knows a lot about, and JavaScript, TypeScript is just a very common and popular thing, so we can leverage the LLM understanding to tap into its code generation capability. Data, most naturally, is in JSON, which is a JavaScript object notation, which allows you to specify the actual fields and map the data and the relationship between the data. So It is a relational system. So when you have a data file, you say, I have an invoice, and it's a data, and then say, well, what are the fields in the invoice? And there will be a TypeScript file, the code that defines it. But you can also link them together. Say, I have an invoice that links to a vendor. A vendor is also defined in vendor.gts as a file. And then you can kind of build up this relational system that way between the definition and instances. Now, we're getting ahead of ourselves. From a coding assistant point of view, this code and data are just saved in the file system as part of the stack. So there are GTS files, which is just a file, and then there's a bunch of JSON files that corresponding to each of the instances you've created. If you have 5 vendors, then there's 5 JSON files. If you have 100 blog posts, there's 100 JSON files of that type. And if you want to just ignore like traditional UI and look at yourself like, I'm just going to cursor to or VS Code to play with it, you can actually edit this code and data entirely using just a file system, and the system will work. It's just a record of everything you made. It's a file as the main abstraction. But remember, we say we really want to be able to query this information, and searching and looking for files of a certain format is pretty hard to do unless you compile and index it. What does it mean by compile? Compiles mean we take the code and we construct a database to store your data that's defined in your code. So there's a table with vendors and stuff like that. And then so the GTS file, which is the code, gets to become a definition of how you construct a database to actually store that data, as well as the actual relationships between the data. The indexing part is that when you save 15 files, I would like to insert those actual customer data into the tables. And we do it by way of SQL. We use Postgres as the implementation. We also have a client-only implementation using SQLite, where it actually constructs a full-fledged database using only the definition and instances that's stored in the file system. And then we expose this information through an API, a RESTful API, so it becomes a server. And then if you have an application, and this application is served out of that, remember the code is in the database, right? Because your code is in the file system, so it shows up in the database. We actually serve that file, which is HTML file. So this is actually a JavaScript application that's served out of our indexer. And that indexer database will then be able to just render what has already been pre-created. But if it needs new information, let's say it needs to look for related articles and stuff like that, it can actually query the database for other card instances that match a certain criteria. So the hosted software aspect is not really what's being deployed. What's being deployed is just the code and data. There's an illusion that you have this app, but the illusion of the app is just reading out this compiled and indexed artifact that comes out of this file system. Now, this is the AI part. Now that you have this hosted software, if you want to have this AI capability, let's say translate something to French or convert a particular note into a structured format like a report or something like that, you can send that file, the HTML file or the JSON or any artifacts that exist in the system, to a chat network through a bot. A bot will say, oh, someone has sent me a card, like this JSON file, whatever it might be. Let me forward that to an LLM. So we'll actually take that information and send it as an input, going from the short-term memory to the muscle memory, and get back a new piece of information. That information can include additional instructions like, oh, before I can help you link your update your calendar, I need to know your calendar appointment for the next week. Then it can actually ask the bot to ask your database for your calendar, and then continue churning within this chat network to ultimately say, I found the API, I've updated certain information. Now I can go back and update your application so that I replan your week. And that will use an API that's exposed by your application. So this Java application has APIs and can call that through a commands model. And when that's done, when you actually have updated the app then updates the data file itself, and that then goes back to the file system, gets re-indexed, and in some cases update other cards if it's an aggregate coming on. So this is actually the life cycle of these files that's been stored in the Cardstack environment. So when the user update data and update code, what they're updating is their own information. Each user have identity, and that identity gives them what we call realm. A realm contains the stuff that you've created within this kind of like account. You can create multiple realms the same way you can create multiple folders or use different drives to separate your work. And that particular realm system is really powerful because it allows you to put your personal information in one realm and your shared information in your team in another realm. And there could also be a realm that is like public reference information, like a Wikipedia, right? Very few people can write to it and publish to it, but everybody can read from it. So this, you can build apps to tap into one or more realm so that your apps are not tied to a particular set of data. It's very, very flexible to be able to kind of synthesize different things together. When the bot goes and call an API, an LLM, there will be a cost. But because this information is actually running within the user's account, the user can say, oh, I was running this report generation code that I copy and pasted on the internet or I got from another friend of mine. When you need the AI, you actually pay for it with your own credit. So the bot will deduct credit from your own account. And this is a really fantastic feature for AI developer because if you do not provide a way for people to pay for the AI credit, then you are essentially providing credit in a loaning money to the user to use the app. And a very popular app can easily burn up thousands of dollars of, if not hundreds of thousands of dollars of AI charges. So this approach of letting the user control their own realm, which contains the code in the app that they run, is that when they run the app themselves, they're paying for the credit to run the app. Another nice effect is that the AI creator, the person who created the particular app, which is code, actually doesn't see your data because they gave you the code. You're running the code in your own realm. They might get paid because the bot recorded who used the particular app and how much money was, how much credit was used, and then we can give a royalty or a commission of sorts to the persons whose app triggered a particular economic monetization on this network. And then finally, we actually built our chat network on a real chat protocol. A lot of chat bots are not real chat systems. They're just kind of pretending to be chat. We actually built it on a chat protocol and an open source one called Matrix. And that means that your chat can federate with other people's chats. So you can have a bot that is listening to submissions from users and doing automation. And that same network that is orchestrating the integration with LLM can also orchestrate exchanges of data and code between organizations through this federation means. So that's it. That's roughly what goes under the scenes in Cardstack. And by having this compressed stack underneath the AI apps, we can now simplify the AI app to just be these code files, these like single JavaScript file that describe a capability and not have to worry about the full stack. So if you can create a new chess game on an AI app, it's one file, not 100. So Cardstack is the platform. On top of this platform, we can provide a playground for application developers, software composer, or vibe coders to build AI apps. And the type of AI apps you can build is pretty wide. It can be actual AI generation apps, so apps that taps deeply into our AI bot features. When the user clicks on a button, make recommendations, and then update the recommendations on their form based on the output. It could be code generation, which is what we're discussing today, where there is ability for the user to use an app to write new code. Like, I want to customize this landing page to contain these things. Then instead of writing data back to your file system, which is how we store the root truth of it, we are updating the code file. There's no difference between code and data. They're just stored in the file system. So you can update either one anytime. So you can actually do app generation with the same infrastructure as content generation. There are sometimes you want an app with built-in AI functions that you don't want to expose that there's a chatbot. If you're making something to sort something into categories or something like that, you don't need to like constantly chat, please sort anything. You just want to have like sort and then have that button do the action. So the function is entirely automated. You don't see the chatbot. It actually uses a chatbot underneath to perform its action to share that short-term memory, but we can hide the assistant while that happening. So this will be something that will look like a traditional application, even though the capability of the short-term memory chatbot is actually what's powering the capability. And then this final part of discovering app via AI is actually pretty significant. But the idea here is that code generation, or any type of generation in AI, to be frank, you have to ask the question, do you have to generate it again? If you generate it for one user and it's good enough for other people, like an answer for Perplexity, maybe you just give that same answer. If someone asking, when is the Super Bowl? That answer doesn't have to be generated each time. There may be a way to cache it. Same thing with app generation. Someone say, I want a sign up form, has these kind of basic email addresses. Why do you have to make that again from scratch? You can just look for, using the query feature we talked about earlier, and search an existing catalog of already generated software, the social aspects of it, and say, hey, I'm not going to generate it again. I found one that would be right for you. Let's just use that and keep it going. And that reduces the amount of credit usage to do the AI, but maybe free up some credit usage to pay a tip to the person whose template you're reusing. So this idea of sharing of the code, sharing the source code, is a real opportunity to not only think about this as a drawing from this muscle memory new things all the time, but also starting to codify and catalog and organize the stuff that's been generated or extracted out of this LLM and start sharing those things with humans, but also with the AI itself, so we can build increasingly complex or compositional things without having to go back to make a button or something like that. The button's already been made. Why can't we reuse it? If you look at what is actually happening with a lot of the good code generator, it knows a lot of library. It's importing a lot of already created UI component that looks and feel great. So it's already doing that. We're just adding on top of it beyond the component library, actually having fully functional application, which we call cards, be reused in this retrieval cycle, either by the user choosing it or the AI choosing something that already exists in lieu of generating it from scratch. So I'm going to give you a little demo of the Boxel environment to kind of show you the structure of how elements that we've talked about is actually done. So this is my personal workspace, sys. So I've created multiple to segment different things, try different out. There's an experiments workspace. So this will be a realm. So it includes a database. So these are database of all the authors I've created, some bookings, ability to look at a CRM account. So these are different vendors, customers, deals. So these are CRM concepts. I've various type of currency that's in the system. And if you keep looking, there are actual games that you can play with, like a New York Times game. So when you look at it this way, this looks like a database where you can filter all the cards that exist. This is like documents in thumbnail form, or you can filter to only one type about. So I have a video product or something like that, and I have a product page. So these are like the documents. The file system, we have something called code mode, which is a bit of an advanced mode, but it does show that this realm, experiment realm, has these files, like these GTS files, which is code, right? It include blog posts, has a, let's see, blog app, has the website, and booking has certain fields, start time, end time. This is the actual definition of the schema. So the fields of title, venue, we have a visualizer of it. If I change the fields here, it will update here, and it makes it easy for you to know what's going on. But there's also data, right? So we have these blog posts that we talked about just now. And each one of these blog posts have different instance data on them. And these data is in JSON. So this is exactly what we talked about early on, is that we mixed both the code and the data in a file system. But nobody really needs to spend time understanding how the code works. You can just look at it as a more traditional person. You can even make an index app that makes these blog posts look like a database, and you can filter them and resort them as if they were database entries. You can also link them together. I end up making this Chinese. Let's find another one. And you can create linkages between that and an author, and link these people to each of those blog posts. me see if I can link them. So I link it to this person. Now this is now tagged to a that particular author. So this type of linkages in a blog post is obviously very simple, but it can be a lot more sophisticated as you go to CRM app. You can link a deal to a vendor, an account. So this is for fitness gym. I can link it to a different CRM account, pet clinic. And that creates the relational database where you can now see your deal. This is going to Paul Kennett. So if I want to interact with this information using a AI assistant, if I like the McDonald's book, it recommended other books. This is just a document, right? So this is just something that has these books involved in it. If one way to look at how the document is structured is just look at its standard edit view, which will tell you all the data that's being captured here, the ISBN and the title of the book. We get the cover using the ISBN. It's not generated. So if you go back here and say, I have a new book in mind, I want to see if I can ask the AI for help. What I can do is just to trigger the AI assistant. The AI assistant now would say new session, and I say, I have a new book in mind. I'm reading Harry Potter. Okay. And I think it's J.K. Rowling. Something, right? So I saved it, and I can ask the AI to say, can you fill out the info for the book I'm reading? And what this does is that it sends this particular book recommendation, which is blank. So now that I have chatted with the AI with enough specificity, it can now retrieve this information from his kind of training memory. And then I click this button. It is now applying this information to this file. What's cool about this is that if I come here, it's actually filling in all the information because the actual data is now informing this template, the code. So if you actually look at the code for book recommendation, right? So we can go to the card definition. We can just always navigate from an instance to a definition. This is just a template that has the sections for the recommendation, a section header, and then some CSS style sheet to make it look pretty and using a font, right? So once you have this filled out, then you can follow up on list the remaining books in the canonical series. So what I'm asking it to do is to come up with these add books. Instead of me typing it in one by one, I want the AI to do it for me. So I apply and say, please do it for me. Now it went ahead and just completed the series by adding the information of the ISBN number and the title for that. Now I have this book review thing. But unlike a chat history, this is actually in my long-term memory, in my realm. So if I actually look at this book recommendation filter, now I've added this recommendation. The other recommendation I did for 3-body problem is still there. So this is my data in my personal realm. I can then say, given this set of recommendation, I can add the card here. Please give me additional recommendations. So I can continue that chat using any assets I have here that has been already created already. So hopefully this gives a little overview on how the basic Boxel environment work. So the number of apps in the Boxel environment can grow dramatically because it's just JavaScript, but they can tag together. So the Business Hub, the CRM app, can be augmented to do accounting, can do like time and attendance, can do employee or candidate tracking and linking to the same staff names and stuff like that. So zooming out a little bit, the role of the framework, the Cardstack framework that's underlying it, is ensuring that we can do a bunch of stuff that is hard for the traditional stack to do. One is we have completely eliminated deployment. So when you save a file, when you just like patch a file or update some code, it automatically make the changes. There's no deployment. There's no separate step to push it live. Everything is live all the time. It's like updating a spreadsheet. Once you put a new formula, it's live. Even though what's going on here is we are actually doing under the scene all the type of JavaScript front server-side deployment that you would expect to come from a system like this. We do this by maintaining real code. It was something that we early on decided. There's some part of the journey within making Cardstack where we thought we were going to make a no-code tool by making it easier. But we realized that code is a fantastically powerful thing that you can express anything else. So we actually pivoted from a no-code tool to a real code tool. Now, obviously, writing real code is a bit tricky, but with AI, that's not hard at all. With vibe coding, you can just write new code. So as long as people get better at using LLM or LLM getting better and more library, you can build pretty much anything that runs on that platform because it just runs JavaScript code. A lot of the data logic for querying is actually real data logic that goes to make a query in this database. So when you say, give me my next 10 days worth of appointment, it will make a query. It's not asking an LLM to summarize for you. So there's no chance that like imprecision will come up. Now, if you want the AI to like suggest the next thing you do, it will take the query and then analyze that query. But there's a real data logic underpinning what the user can tap into and what the AI can tap into via the RAG process. And finally, real personal memory, which means that you can be using multiple apps, some for book recommendation, some for workout recommendation, some for music recommendation, and you can combine together. Say, hey, I like this music. Based on this music, what book should I read? That's really hard to do if someone was making an app and deployed it using Replit or something like that. And whatever data that they store, it's in a silo. You have to log in and you say, how do I get that data back to ChatGPT? How do I get that data back to my next step of workflow? By using this realm system, everything you create with AI or by yourself in the app can be used as this long-term memory for future conversation, and they can break boundaries. You can link them and copy them from one domain of your life to another domain of life without worrying about having different web services or web app silo your data together. In terms of the UI, which is the Boxel app, we didn't talk too much about what Boxel is for. Boxel is a consumer-facing product. It's hosted at Boxel.ai so that you don't need to install or know anything about open source to run Cardstack. So it's a service we provide to people that provides a Boxel credit system. So you can have the billing built in. You just set up one billing relationship with Boxel and you can use those credits. Use any AI app that's distributed through Boxel in the Cardstack ecosystem. But if you think about what the UI for Boxel is really doing, is helping you prime the prompt, which is to say, before you click this button, we already gave a lot of information to the LLM how do we deal with it. So when we were looking just now at the ability to update a page, we already sent out a skill called card editing to teach the AI everything it needs to know about how to interact with cards in the Cardstack system. We can attach these skills before you type anything. Just by clicking the right button within the UI, we kind of prime the assistant to learn about or to know about, oh, please update my attendance data. Oh, this is attendance update skill that someone has written, like a custom GPT, that we could just prime the prompt so that you can be successful right away without having to teach the AI all the stuff. And this is done by taking the long-term memory, things that's already been created, and sending it back before you do. It's almost like transferring a call between a customer agent. They already have your profile because they were brought along before you even get on the phone with the level 2 support person. And one way to make the prompt priming even better is for the community, not just an individual, to share what they've created. And that's what we're going to do. And we're working on this right now. It's called the catalog software, which is setting a realm, same as your personal realm, but it's shared. It's public. like a Wikipedia or like a library of stuff, right? Where it becomes a collective memory of everything that people have made. If someone made an invoice generator, they can share that and upload it. Every other person who needs an invoice can just use this as a starting point. And that allows us to build up this collective usage pattern so that it becomes easier and easier to prime the prompt by using previously created prompt that other users on the Boxel system has already created. So this is what we mean on our website on Boxel.ai as composing your own software. It's not just composition for creating new software, but it's really tapping into a vast expanding catalog of components and skills that you can remix and share. Boxel as a word means box element. It came from the word voxel, volume element, which is what Minecraft, you have different blocks, and pixel, which is picture element. So we see these kind of boxes of capability to be reusable and combinable like an open world game. So that people can be able to express themselves in this new way without getting caught in a low-level detail of the traditional stack. So it's a very media-oriented, very game-like, open world-like experience that we want to achieve, and still guaranteeing and providing that deep understanding of how software is built, how it's coded, how it's compiled, and how it's deployed, completely hidden under the skin, but it's always there. As an open source project, obviously, if you want to contribute to the engine, the part that is compressed, that's in GitHub, and you can look at that. So that's what the current state of Boxel is. We believe what Boxel is bringing to the AI system is the next generation of capability and beyond what's currently existing in the more professional cursor-based or more fun type of experience you get in the generative AI arena. So I've included an early access code. We're still in a early access invite only phase to make sure that we can learn from what people are doing on our platform. If this code doesn't work, you can come to the Discord, discord.gg/Boxel, and then you can request a new code because this may have expired by the time you view this. If you want to check out the Cardstack GitHub, you can go here and see the actual entire platform that's been demoed and even running on your own computer if you're a developer and comfortable with doing that. When you sign up, you get 1,000 free monthly AI credit, and you can try out different features. We currently have a lot of the content features in production, but you'll also be doing code generation features as well. For users who are already using Cursor, we have a VS Code plugin that is available in Cursor that allows you to connect directly into a Boxel realm so that you can update using Boxel's as the renderer. You can use Cursor to make real-time changes to your game or your form or your template with the smooth integration without any updates. So we worked really hard to expose the file system that is backing the Boxel system and the Cardstack framework to make it using the virtual file system capability to make it editable within Cursor, which speaks the file language. So we made that connection. So if you're good at Cursor, you should try us out and find ways you can actually even shorten your software generation lifecycle. So thank you very much for your time and attention. Would love to show you guys more of what we can do in using this deep platform that has been compressed to be usable to push the envelope of what kind of AI apps people can build and what they can share. So again, my name is Chrissy. I'm the founding director of Cardstack Project. I've been working on this project for a long time and very excited and feel very fortunate that the choices we made to make the Cardstack framework using files, using this code as a way to express these new languages, and pick JavaScript as the runtime really align very well with the generative software. And we're working with all our efforts to bring a lot more features and workflow simplifications so that we can compose the software we need for our daily lives in minutes and have everything customized exactly what we want to do and be able to own the data and the relationships that we build using a type of decentralized concept of personal data ownership, open source software sharing, and share monetization if the value that we create end up helping other people. So thanks very much. Until next time, take care.